Hello, everyone. All right, so welcome to the second episode for this week. This week is the final week that we'll be having 3-a-day CSEC multiple choice questions, of course, in 2021. All right, welcome to those who just started with me yesterday. It's okay, never too late to go through the other videos or pick up where we are right now. All right, so we are looking at the May 2011 paper, and today we are doing questions 49 to 51. All right, let's hit the road. We are given a number line, and a part of it is marked off, indicating a range of values. The question says the graph of the inequality in the diagram above is defined by. All right, so we need to note a couple of things, and we also need to know a couple of things. All right, if the first thing you notice is that all these options pretty much look alike with some very small differences, which means we need to know the difference between what these signs mean. All right, once we know that, then we are able to mark the correct answer. All right, so when you want to represent a particular range or inequality on a number line, let's say we have our 0 here, we have the number 3. If I want to mark off values that are less than 3, I do this. I mark that spot 3 with a circle, and I go left to show that I'm indicating values that are less than 3. If I want to indicate values that are 3 and less than 3, so they are less than or equal to 3, what I do is shade. Oops. What I'll do is shade this spot right here. All right, so it wouldn't be an empty circle anymore, but it would be that shaded circle, and I'm indicating 3 or less. So X would be less than or equal to 3. And that's the case in this diagram we're given. We should be indicating that X is less than or equal to 3. So immediately we know this is incorrect. And we know this is incorrect because this one is saying that X is actually greater than 3. All right. Next thing, the next value that marks the other end would be the -2. And of course, let's say that's -2 right there. And we're looking at values that are not equal to, but greater than, greater than 2. 1, right? It's going to the right. So it means any values that are bigger than -2. All right. So again, we would have noticed that this B would have been incorrect because 2 should not be included, right? X should not have a value of 2. X can only be greater than 2. So it cannot be that we are saying X is equal to or greater than. No, this sign here is not shaded. This circle is not shaded. Therefore, we know it must not be equal to -2. Excuse me if I had said 2. All right, so we know now that the values that we're looking at, they are bigger than 2, but they are also less than or equal to 3, and that would have been this. All right, so they're bigger than -2. Excuse me, I keep saying 2. They're bigger than -2, so X is greater than -2, and X must be less than or equal to 3. All right, we combine those two things to get to this this range. All right, and that would have been the final answer. All right. Number 50, what is the gradient of the straight line 2y plus 3x equals -8? Now, in yesterday's video, we looked at the fact that the equation of a straight line looks like this. Y equals mx plus c, where m represents gradient. I also have a song for that, but I'm not in the singing DJing mood today. All right, and c represents the y-intercept. All right, so we're going to ignore C today when we finally rewrite this equation in this form. All right, because all we want to know is what is the gradient. Now we know that the gradient is the coefficient of M. So it's tempting to go ahead and say the answer is 3. That would have been incorrect. Unless the equation looks like this, unless it's in that form, we cannot identify the gradient as yet. So let's go. We have 2y plus 3x equals -8. And we are going to rearrange so that y becomes the subject of the formula. Clearly, that is what we need. Y should be on one side by itself. So let's go. Let's get rid of 3x first. So that's -3x minus 3x. 2y equals -8 minus 3x, right? Again, we need just y, so we're going to be dividing by 2. And by the way, if you want to pause here, we can do this at the end, but if you want to pause here and do it, that's okay. What am I referring to? The fact that you need to ensure it's better visually for some persons to when they have the gradient right here. All right, so the term with x in it, to have it just right here. So -3x minus 8. Here, just rearrange a little. As I said, you could have chosen to do this at the end if you wanted to. All right, divide by 2 because we just need y by itself. If I'm dividing one side of the equation by 2, I do that to the other side as well, which is the same as dividing every term individually by 2. All right, so now we can see that y is equal to -3/2, x minus 8/2. Which part do we want? The gradient. Where does the gradient come? Right before the x as a coefficient. All right, so our answer would have been B. We will now move to our final question for today. It says, which of the following sets is represented by the relation f of x is equal to x squared plus 3. I'm going to rewrite it just as I said it. F of x equals x squared plus 3. All right, we know that f of x also can be rewritten as y. So let me just change it to that for reference purposes. Now we know that each pair of values really carries x and y coordinates. All right, so we know that the first value is going to be x and the second one is going to be y. You can do one of two things. You can say, okay, let me put in the x value. So we're going to test the first one. X value is 0. So 0 squared plus 3. And once we work that out, it's telling us that y should be 3. Is that the case here? Yes. Okay. But let's test the rest of pairs. All right. And you can just put a little note. When x equals 1, y is going to be 1 squared plus 3 using the original formula. So y is going to be 4. Does that happen here? Yes. Continue testing values. Let's see. All right. When x is 2, y is going to be 2 squared plus 3. So y is going to be 7. Does that happen here? Yes. And it will also happen for 3, 12. All right. So of course, A would have been our final answer. All right. I did say you can do it like that, or you can just check if both sides of the equation give the same result. It's pretty much the same thing that we just did. All right. But if you have the original formula, y equals x squared plus 3, and you're testing to see if both sides are equal, you put in both the values for y and the values for x and see if both sides will be equal. So it'll be pretty much something like this. If we're testing the point 0, 3, it would be 3 for the y value equals 0 squared plus 3. Are both sides of the equation equal? Yes. So you know that that would have represented the relation well. All right, so A would have been our correct answer. And that is it for today. Feel free to go back, feel free to pause and write and stuff like that. I should have said that earlier. All right, so I hope to see you tomorrow again. It's goodbye from DG Makes Math Easy. As you know, we're intentional about making math dimensional. I am wishing you all the best in your exams from now. All right. See you tomorrow.